Hello guys, thank you for checking out the new episode of the Devlog and welcome to more than 250 new subscribers since the last episode. That's super cool and motivating, thank you so much everybody. Last month we talked about the custom pathfinding system and the basic movement of the character in the game. The next logical step for me was to create a test scene with placeholder images to work on the layers and the rendering order and to create a first rough draft of the basic character animations. I want the animations in the game to have a frame-by-frame aesthetic, like the classic point-and-click adventures of my childhood. For the most animations, I will use a frame rate of 12 frames per second. This has several reasons. As a solo developer, it is of course important to keep the number of frames as low as possible, because every frame has to be drawn and the workload of a single animation significantly increases with a higher frame rate. Furthermore, frame-by-frame animations require a higher amount of data because each frame of an animation is handled as a single sprite in the game project. On the other hand, 12 frames are just enough to simulate a fluid movement for the eye. In fact, we all are very used to this frame rate because 24 FPS is a standard for movies. So animated movies had to stick to this frame rate as well. And to reduce the effort for single animations, animators sometimes use the method of using a frame twice and thus only have to draw 12 frames per second of animation. This is called animating on twos. In fact, this aesthetic seems to be coming back into fashion as it can be seen in more modern animated films such as the animated Spider-Man movies, the Lego movies and the upcoming Turtles movies and so on. So I thought it was a good call to use 12 FPS as a reference for the start. I decided to use Adobe Animate to create the animations. I used to work a lot with this software when it was still called Adobe Flash and I really hope I can quickly get a good and effective workflow with the program again. For me, when animating, it is always important to work with rough, simple shapes and to work out the rough timing. After that, animations can always be refined and improved pretty easily. So I took the first of the three main characters and reduced him to simple shapes for animating. Then I started animating a classic walk cycle from the side view. This walk cycle lasts exactly 1 second and therefore consists of exactly 12 frames. I started with the legs, then added the up and down movement for the body and head, and finally animated the arms. I did this for all 8 directions the character can move in. Here it already becomes clear why a low frame rate is so important for a solo developer. A 12 frame long animation in 8 directions already results in 96 frames. And I need such animations not only for walking, but also for standing, running and interacting. And I want to implement the whole thing for 3 main characters. So only the most basic character animations for the game already results in over 1000 drawings. After I was done creating a rough animation sketch for walking in 8 directions, I had to ask myself how to best import these animations into the Unity project. It is important to me that I can quickly make changes to the animation in Adobe Animate without re-importing all the frames over and over again into the game project and hoping that Unity's animation files wouldn't get corrupted. And I found a tool called Texture Packer that seems to be very suitable for this situation. I can now export a PNG sequence via Adobe Animate with a simple right-click on the animation. These PNGs are then arranged on sprite sheets by Texture Packer as effectively as possible. I can then export these sprite sheets with 1 click and automatically import them into Unity. The sprite sheets are then already sliced perfectly and can be worked with in the project. So after setting up all the animations in Unity and writing the code for playing the correct animation while moving, it looked like this. Of course, this is far from perfect, but I'm really happy so far. I now have a good basis to work from. I can work freely in Adobe Animate to refine the animations, send everything through the Texture Packer tool, and the Unity project updates automatically. Next, I drew a test scene in Photoshop to see and test the new animations in an initial test environment. I exported the different layers to separate PNGs, imported them into Unity, and worked on a script that handles the layering and rendering order. This is important so that the character can walk around objects and then be rendered behind them. The order in which 2D graphics are rendered in Unity is defined by 3 stages. The first stage is the sorting layer. These layers can be created separately and will be rendered one after the other. I use these layers in the same way as the layers in my pathfinding system. This way I can easily sort multiple layers in a scene, one after the other, and not have to worry about objects being rendered on the wrong layer. So in this scene, for example, all the graphics in front of the hill are on sorting layer A, all the graphics behind the hill are on sorting layer B. For elements in the foreground and background, I use separate sorting layers at the very top and the very bottom. The next stage is order in layer. An integer variable used to specify the order of individual objects at each sorting layer. A larger number means that the object will be rendered more at the front. Here I was able to take advantage of the scaling features of my pathfinding system that I talked about in the last episode of the Devlog. Each object checks for the scaling value on its position. A smaller scale value means that the object must be farther away and therefore has to be rendered further back. This has at the same time the advantage that I can compare the scaling value of an object with the scaling value of the character, and thus easily determine whether the character should be rendered behind an object or in front of it. The last stage of the rendering order is the Z position of the sprite. So if the sorting layer and the order in layers of two sprites is the same, Unity looks at the Z position of the sprites to define which sprite should be rendered in front. I will use this stage later for sorting sprites on a character, for example to render the face expressions on top of the head and so on. But I will deal with that a little later in the development. The last thing I implemented last month was a simple first camera script to be able to pan left and right in a scene depending on the position of the character. And that's it for this episode of the Devlog. I think the next month is going to be very exciting because the next development steps are very big and important ones. Dialogue system, inventory system, overall scene and game logic, and a basic cutscene system. As you may already see in the background, I am currently in the planning phase of how to build and architect these systems in the game. How smooth the later workflow will be to fill the game with actual content heavily depends on the progress in the next few weeks, so please wish me luck. See you guys next month, and once again, thank you so much for your support.